Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel for such more problems. Now I am going to solve this problem 410. In this problem we are required to determine the forces in BE and CE member of this loaded truss, right? So before solving this problem, first we need to find the angle between this CD and this DE member. Let's say this is theta, right? And then we will find this angle. Let's say this angle is alpha, right? Now as we can see that we are given this, that BC, this BC length is equal to CD length, right? This is given. Now as we can see that if we look into this ABD triangle and this BCD triangle, they are similar triangles, right? So this means that if they are similar triangles, so if this AB and this CE are parallel to each other, and if they are the sides of a similar triangle, so this means that if this AB is making 45 degrees with the horizontal, so then the CE will be making 45 angle with the horizontal, right? So this angle is 45. Now to find this theta, let me consider this perpendicular, right? So if we apply tan theta and let's say that this intersection point is, let's say, H, right? So now if we consider this BHD triangle, right? So we can find this theta, we can apply tan theta. So I will write tan theta equals to, if we consider this BHD triangle, right? So tan theta will be equal to BH divided by this DH distance, right? So I will write DH or HD, right? So BH or DH, right? So now as we can see that we are given this 3 meter length and this angle, so this means that this BH is the sine component of this 3 meters, right? So this means that this is 3 sine of 45 degree. So we can write that theta is equal to tan inverse, and BH is 3 sine of 45 degrees. And as we can see that this AD, this whole length is how much? So this whole length is 6 meters, right? So we can write that this DH length is 6 meters minus this AH length, right? So we can write that DH length is equal to 6, or we can say that this is equal to AD length minus AH length, right? So AD is 6 and AH, this AH length is the cos component of this 3 meters, right? So this is 3 cos of 45 degrees, right? So we will write it here. So this is 6 minus 3 cos of 45 degrees. And when we solve this, so theta is 28.7 degrees, right? Now we can find this alpha as well, right? So if we find this alpha, so then if I apply tan theta to this small triangle, this BHE triangle, so if I write tan alpha, so then again this tan alpha will be BH divided by this HE or EH, right? So let me write that this is EH. So alpha will be equal to tan inverse, and BH is again 3 sine of 45 degrees. So I will write 3 sine of 45 degrees. And now this time this HE length is AE minus this, right? So we can write that EH is AE minus AH, right? So we will write AH. So AE length is 3 meters, this is given, minus AH is again the cos component of this 3 meters, right? So this is 3 cos of 45 degree, right? So I will write 3 minus 3 cos of 45 degree, and this alpha equals to 67.5 degrees, right? So now we know this theta and this alpha angle, right? Now as I have told you people that this triangle ABD and CED, they are similar triangles, right? So we can find this CE length by using the properties of similar triangles, right? So we can take the ratios of the corresponding sides of similar triangles, right? So we can write that CE divided by this length AB, which is 3 meters, will be equal to this DE, which is 3, divided by this AD, right? So AD is 6. So this means that CE is 1.5 meters, right? If we solve this. So now this CE length is 1.5 meters and this alpha is 67.5. So we will write it 67.5 degrees and this is 28.7 degrees, right? So now if we apply the summation of moment at point A equals to 0 to the whole truss, right? So now as we can see that this 5 kilonewton force is producing clockwise moment about this point A. So I will write, let's say that the counterclockwise moment is positive, right? So this 5 kilonewton force is producing clockwise moment. So I will write minus 5 and the perpendicular distance of this 5 kilonewton force from that point A is this much distance, right? So this much. This is that similar H point, right? So this is the cos component, right? So I will write 3 cos of 45 degrees. Similarly, this 3 kilonewton force is producing the clockwise moment about that point A. So I will write again minus 3 and the perpendicular distance of this 3 kilonewton force from that point A is this much distance. Let's say that this is point G. So this AG distance. So this AG distance is equal to AE plus EG, right? So AE is 3 meters. So I will write 3 plus this EG. So EG is the cos component of this 1.5, right? So I will write plus 1.5 cos of 45 degrees and we haven't represented the reactions at point A and D. So since this is a roller reaction, so there will be a reaction in this direction at point D. This will be, let's say, dy, and there will be two reactions at this point A. Since it's a pin joint, so there will be a y reaction and there will be one reaction AX, right? And if we represent this as our positive x and positive y direction, right? So this dy will produce the moment about A in the counterclockwise direction. So I will write that is plus, and the perpendicular distance of this dy from that point A is this 3 meters plus 3 meters, right? So this is 6 meters. So this is 6 dy and this is equal to 0. And when we solve this equation, so the reaction at point D in the y direction equals to 3.80 kilonewton. Now we will start from this joint D, right? So if I draw the free body diagram, so let's say that this is the DE force. Let me write that this is DE and the dy reaction is acting vertically upward, right? So this is dy. And similarly this CD force, right? So let's say that this CD force is acting towards this joint, right? So let's say this is that point D and this is that CD force, right? And as we know that this angle is 28.7 degrees, right? So now if we apply, let me write that this is at joint D, right? So if we apply the summation of forces along y equals to 0, so now if we resolve these forces, right? So this FCD will have one component which will be acting downward, right? So this will be the component of this CD and this is the sine component, right? And it is acting in the negative y. So I will write minus CD sine of 28.7 degrees and this dy is acting in the positive y direction. So I will write plus dy and this will be equal to 0. And when we solve this, we know this dy, right? So dy is 3.80 kilonewton. Let me write it here. This is 3.80 kilonewton. So from this equation CD, the force in CD member is 7.91 kilonewton. And as we can see that this CD force is acting towards the joint, right? So this means that this is the compressive force, right? And now if we apply the summation of forces along x equals to 0, if I write the summation of forces along x equals to 0, so this CD force will have one component which will be acting in this direction, right, and this will be the cos component. So I will write that this is CD, and now we know CD magnitude, right? So this is 7.91 cos of 28.7 degrees, and this DE is also acting in the positive direction, right? So I will write plus DE, and this will be equal to 0. So this means that DE is equal to minus 6.938, right? So this is 6.938 kilonewton, right? So this means that the DE is acting in the opposite direction, right, since we have minus sign here, right? So this means that DE is acting away from the joint, right? So if it is acting away from the joint, so then this means that this is the tension force, right? So we will write that this is DE is, if we consider DE as positive, DE is 6.938 kilonewton, and this is tension force, right? Now we can represent that CD force here in this diagram. So CD force is compressive force, so it is acting towards the joint. DE is tension force, so it is acting away from the joint. So at this joint C, this CD force will be acting towards the joint since it's a compressive force, and here it will be this DE force will be acting away, right? So this is DE and this is that CD. So now if we consider joint C, for calculation, right? So let me write that at joint C, if we draw the free body diagram, so this is at joint C. So this is that 3 kilonewton force, 3 kilonewton, which is acting vertically downward. This is CD force, right? So CD force is how much? So CD force is 7.91 kilonewton, and as this CD force is making 28.7 degrees, so if I draw a horizontal line here, so this angle is also 28.7 degrees, since this angle and this angle are alternate angles, right? And this magnitude is 7.91 kilonewton. This is CE force, which is not known, right? And this is BC force, which is not known as well, right? So now if we apply the summation of forces along x equals to 0, as we can see that this CE force, or this CE member, is making 45 degrees, so then this angle is also 45 degrees, and if this is 28.7 degrees, so then this is also 28.7 degrees, since BC and CD are parallel to each other, right? They are acting along this same line, right? So if I apply the summation of forces along x, so then as we can see that this BC force will have one component which will be acting in the positive x direction, and that is the cos component. So I will write BC cos of 28.7 degrees. Similarly, this CE force will have one component in the negative x direction, and that is the cos component, right? So I will write minus, that will be CE cos of 45 degrees, and this 7.91 has one component which is acting in the negative x direction, so I will write minus 7.91 cos of 28.7 degrees, and this is equal to 0. And if we simplify this, so then this is 0.877 BC minus 0.707 CE, and this is equal to 6.938, and let's say this will be in kilonewtons, and let's say this is equation A, right? And similarly, if we apply the summation of forces along y equals to 0 at joint C, so as we can see that this BC force will have one component which will be acting downward, right? So it will have one component like this, and that is the sine component, right? So we will write minus BC sine of 28.7. Similarly, this CE will have one component which will be acting downward, and that is the sine component. So I will write minus CE sine of 45, and sine of 45 is 0.707, right? So we can write that this is 0.707 CE. And similarly, this 7.91 will have one component which will be acting in the positive y direction, so I will write plus 7.91 sine of 28.7 degrees. And similarly, this 3 kilonewton force is acting downward, right, in the negative y direction, so I will write minus 3, and this will be equal to 0. So now if we simplify this, so then this is minus 0.480 BC minus 0.707 CE, and this is equal to, if we solve this and bring this to the other side of equation, so then this is minus 0.798 kilonewton, and let's say this is equation B. So now if we subtract equation B or equation A from B, right, so let me write equation A here. So this is 0.877 BC minus 0.707 CE equals to 6.938, right? This is equation A. If we subtract equation A from B, right, so I will have to interchange the signs, right? So this will become the plus minus, right? So this will cancel out and we will be left with minus 1.354 BC, and this will be equal to minus 7.736. So from this, BC is 5.713 kilonewton. And since this BC is acting towards the joint, so this means that this BC force is compressive force, right? So we will write C with it. Now if we substitute this BC value in this equation B, so then we can find that CE. So from equation B, CE is equal to, this is minus 0.798, and this will become positive on the other side, right? So we will write plus 0.480 into this BC, which is 5.713, and we will divide this whole by this CE coefficient, right? So this is 0.707 minus 0.707. So from this, CE equals to minus 2.75 kilonewton, right? So this means that the assumed direction of CE is not accurate, right? So CE is acting towards the joint. So we can say, if we make it positive, so then this means that CE is acting towards the joint, and this is the compressive force, right, at joint E, right? So let me write at joint E, and if we draw the free body diagram, so at joint E, this CE is compressive force, right? So this CE is compressive force, so it is acting towards the joint, right? So similarly, it will be acting towards the joint here as well, right? So let's say that this is that joint E, right? So this DE force is acting away from the joint, right, since it's a tension force, right? This is the DE, and CE force is compressive force, so it will be acting towards the joint E. This is that CE, and whose magnitude is 2.75, and this CE is making 45 degrees. Similarly, the AE magnitude and direction is not known, so let's say that this is that AE force which is acting away from this joint E. And similarly, let's assume that this is that BE force, right? And this BE force is making 67.5 degrees. This is that angle alpha, right? So we have determined this already. So now if we apply the summation of forces along y equals to 0, so as we can see that this BE force will have one component which will be acting in the positive y direction. So I will write BE sine of 67.5 degrees, and similarly this 2.75 has one component which is acting in the negative y direction, so I will write minus 2.75 sine of 45 degrees, and this will be equal to 0. So from this we get BE equals to 2.10 kilonewton, right? So we were required to find the forces in member BE and CE. So CE member force is 2.75 kilonewton, this is compressive force, and BE member force is 2.10 kilonewton, and since this BE is acting away from the joint E, so this means that this is the tension force, right? So this is the solution of this particular problem.